Today we're going to look at another piece of the triangle like we had yesterday with perpendicular bisector and angle bisector. Today we're going to look at what's called the midsegment, and then we'll also take a look at what the midsegment theorem says. So midsegment is what we're going to look at. So a midsegment on your handout, as you open it up from first page to this page, a midsegment is a segment that connects the midpoints of two sides of a triangle. So, for example, we have this triangle here. So if we find the midpoint, we'll call it A. And we find the midpoint on this side, so we have congruent segments here and congruent segments here. This, we'll call this B. So AB is a midsegment. So that's what the definition of a midsegment is. And a lot of times we'll find the midpoint of the other side, so we'll have a midsegment on all three sides, and it makes a smaller triangle. So we have midsegments that we can make on all three sides of the triangle. But the important thing is that these are made by midpoints. So A, B, and C are midpoints. So A, B, and C are midpoints. So the theorem says that the segment connecting the midpoints of two sides of a triangle is parallel to the third side. So that means this is our midsegment here. So the first part of this theorem, parallel to the third side, says that when you make the midsegment, this side, we'll call AB, is parallel to this side, which we'll call DE. So the first part of the theorem states that the midsegment is parallel to the third side of the triangle. So it's the midpoint on this side and the midpoint on this side. So the midsegment will be parallel to the third side. So these are parallel, which then produce some congruent angles based on the parallel lines that we've already covered. The second part of the theorem says it is half as long as that of that side. So for again, AB and DE, so AB is equal to half of DE. So for example, if DE is 20, AB would be 10. So the theorem states that AB, the midsegment, is parallel to the third side of the triangle. So AB is the midsegment of the two sides that you find the midpoint of, parallel to the third side, and it's half as much as that third side. So if DE is 20, then AB would be 10. So AB, the midsegment, is half of the third side of the triangle. So that's what the midsegment theorem states. So we have two examples to look at here using that. So it says use triangle ABC where X, Y, and Z are midpoints of the sides. So X is going to be the midpoint of side AB. Y will be the midpoint of side BC. And Z will be the midpoint of side AC. Therefore, these are midsegments. Midsegment, midsegment, and a midsegment. So it says XY, which is right here, XY, labeled in red, is parallel. So it's the midsegment between AB and BC. So it's parallel to the third side of the triangle, which would be AC. It then says CB. So CB is here. It's parallel. So it'd be the third side of the triangle for the midsegment XZ. And they obviously look parallel. The next question says ZY is 6, that's the side. Then AB from here to here equals, well, it's midsegment, so it's half as much as the longer side, so it would be 12. CY is 7. So what is ZX? Maybe some different colors. So CY is 7. So what is ZX here in blue? Well, again, this is a midpoint. So if this is 7, then the side over here is also 7. So this whole segment would be 14. And ZY is its mid-segment, so it's half as much, which would be 7. And in one last color, AC. So AC, the whole thing here is 18. What is XY, which here? It's mid-segment, so it is half as much, so it would be 9. So if you find its mid-segment, the longer side, it's half as much. In our second problem, we're going to deal with a few problems with some algebra. It says RS is the mid-segment of triangle DEF. So RS is the mid-segment, which would mean it's parallel to DE and half as much. So RS is half as much as DE. That's our formula. So it tells you on this first problem that RS is 4x plus 5 and DE is 3x plus 25. What is RS? So that means we have to find x. So again, RS is half as much as DE. So RS is 4x plus 5, and that is half as much of DE, which is 3x plus 25. Alright, so we're going to go through solving this. So I'm going to put a little extra room down here. You have some room on your paper above. So when you have a problem like this, which I'm just going to repeat down here so we can talk about how to solve it. So when we have a problem like this, the easiest thing to do is to get rid of this 1/2. So if you multiply both sides by 2, you can get rid of the 1/2. Now when you do that, you need to multiply all of this by 2. So this would be 8x plus 10 equals 3x plus 25. And then we're going to solve. So we'll subtract 3x. (5x plus 10 equals 25). Subtract 10. So x is 3. Once we do that, it does ask us for RS. So RS is right here. So we'll substitute back in. So it's 4 times 3 plus 5. So 12 plus 5 is 17. We want to check our answer and make sure we're right. We can do this one. 3 times 3 is 9, plus 25 is 34. And 17 is half of 34. On the second problem, it tells us a different DE. I'm going to set it up the same type of way. So this time DE is 2x plus 12. And RS is 2x minus 2. Remember, RS, the mid-segment, is half as much as DE. So RS is 2x minus 2, half as much as 2x plus 12. I'm going to multiply both sides by 2 to get rid of the 1/2. So this will be 2 times 2x minus 2 equals 2x plus 12. So 4x minus 4, distribute, equals 2x plus 12. Now we're going to solve. So subtract 2x. This time it's looking for DE, so we don't want to forget that. We'll add 4. So x is 8. So after we solve and we find x is 8, we'll plug that back in. DE is the bigger segment, so 2 times 8 plus 12 is 16 plus 12 is 28. And 2 times 2 minus 12 is 16. Minus 2 is 14. So that is half as much. So DE is 28. There are 2 My Math Labs up for you to work on, and we'll look at a few more of these tomorrow when I come back in. There are 2 My Math Labs. There's a 9A that goes with the perpendicular bisectors and angle bisectors we covered yesterday, and there's a 9B that goes over mid-segment. This one is open till Friday, and the 9B is open until Monday. Don't forget, on Friday this week, we are assessing our learning targets numbers 1 through 7 with your second cumulative. It'll be 30 questions in 60 minutes. So after you finish this, you should be working on your My Math Lab. We'll do a little bit more with mid-segment tomorrow when I return.